Morning, Year 12. Here's a quick starter question for you before we move on with the binomial, just to see if you can answer this one. Pause and have a go. Now I've started it here. I don't know whether some of you might feel ready to move away from this step. I mean, you know, if you are comfortable doing this, I don't want to upset the apple cart at all. But what we've been doing so far is we've been doing it with A's and B's and then replacing A and B with something. I wonder if you might feel ready to go straight into the substituted version. Like I say, if that's going to confuse you, then stick with this and then replace A, in this case, with 2 and B with AX. But there we go, I've jumped straight into that. Remember the coefficients, you can either use Pascal's triangle, you're looking for the row with 7 values of the power of 6, or you can use your NCR button, so that's 1, 6, 15, 20. That dot means multiply, so I could just put the 6 without a dot, but sometimes people use that. Anyway, I want the x squared coefficient. That's going to come from here, isn't it? So that term is 15 times 2 to the power 4 is 16 times, and this is the bit the mistake often happens, ax squared is a squared x squared, and so 15 times 16 is 240. And we're told the coefficient is 60. So therefore, the coefficient, which is 16, so a squared is 60 over 240, which is a quarter, and therefore a is plus or minus a half. Well done if you got that correct. Now, I did say I would make reference to the independent study questions in this lesson. I'm conscious I've got quite a bit to get through, so what I might do is save that for Thursday, and of course Thursday is going to be my first, and maybe only, I don't know, attempt at a live lesson. So I'm going to do it twice. I'll do period 1 for 12B and period 2 for 12E. So I will probably have a look at those questions in that lesson. So I'm going to set that up over Teams. I guess you'll probably get an email inviting you to that. It's new to me as well, so you probably know more about it than I do. Anyway, forgive me for pushing on, but by all means email me if you're really, really struggling with those independent study questions and you're desperate for an answer ahead of Thursday. Okay, a plus b to the power of 10. Just write out the first 3 terms for me. Okay, just pause and do the first. Now let's go for 4. First 4 terms in that expansion. Okay, so I've got a question for you. Hopefully you were okay getting that far. But my question is this: what would happen to successive terms in this sequence if a was 1 and b was a tiny number, close to 0? So b was, you know, between 1 and 0, but tiny, close to 0. What's going to happen to successive terms in that sequence? Well, I hope you can see that obviously the power of a is just going to be 1 all the time. And although these numbers, the coefficients get bigger, although they don't keep on getting bigger, there's symmetry, they start getting smaller again. This number is going to get smaller and smaller and smaller. I mean, for example, if b is 0.1, then this would be 10 times 1 times 0.1, which is 1. But 0.1 squared is 0.01, it's 100th. So this would be 45 times 1 times 0.01. So that would be less than a half. And 0.1 cubed is 0.001, it's 1,000th. So this number would be even smaller, even though you're multiplying it by 120. 120 thousandths is not very big. And successive terms will get smaller and smaller and smaller and smaller. And we can use that fact to allow us to approximate values of quite complicated calculations using the binomial expansion. So that's my objective for today, using the binomial expansion for approximations. And I'm not just talking about rough answers. I'm talking about approximations so good that actually we can use the answers to the approximations in place of the real values, or more importantly, they're sometimes the way that calculators work out the answer to complicated calculations. Let's look at some examples. Okay, find the first four terms of this expansion, a minus x over 4 to the power of 10. So do that for me. Be careful. Remember, b in this case is going to be minus x over 4, which means we've got to be careful when we do powers of that. Pause and have a go. Sorry, it's quite early. I'm making mistakes. Notice I've gone straight to the expansion without doing the a plus b step. Please feel free to do the a plus b step if that makes you feel more comfortable. Brilliant, absolutely fine. But I punch the air when a is 1 because I know that this is always going to be 1, isn't it? This coefficient, whatever the power is. We'd done power of 10 in the previous example, so I had my coefficients there ready. So the only fiddly bit is the value of b, which there's no b there. Got b squared, b cubed. So this term here is 10 times 1 times minus x over 4. So that's minus 10x over 4. And I can write it like that, or I can write it as 10 times x over 4. It's the same thing. Here I've got 45. This is going to be minus x times minus x is plus x squared over 16. So I get 45x squared over 16, which I choose to write as one fraction. And then here x minus x cubed is minus x cubed. 4 times 4 times 4 is 64. So you get 120 times 1 times x cubed over 64, times minus x cubed over 64, which is that, which I'm choosing to write like that. Okay, so let's now use that for an approximation. I want to approximate this to the power of 10. So have a look at this and tell me what x would have to be in order for the contents of the bracket to equal that. I'm going to pause there, get you just to consider that. What would x have to be so that that bracket equals 0.975? Hopefully you could see that x was 0.1, and sorry, it's gloomy today, I'm trying to brighten the light up a bit. If x is 0.1, then 1 minus a quarter of that would be 0.975. So if I make x equal to 0.1 in this expression, I start to get an approximation of this. Now I've only done 4 terms, and of course the full expansion would have 11 terms, but let's do that for now. So I'm going to do this, but I'm going to replace I'm going to replace x with 0.1. So I've got 1 minus 10 lots of 0.1 over 4 plus 45 lots of 0.1 squared over 16 minus 120 lots of 0.1 cubed over 64. And I typed that in on my calculator as just like that. So I didn't bother working out each individual term. I typed it in and I got this answer here, and that's not a rounded answer for this. It's now okay. You're saying, well, it's not equal to that because you haven't bothered to do the full expansion. But that goes back to my previous point. This term, if we work it out, if you don't believe me, try it, is tiny. And the next term, 0.1 to the power of 4, is tiddly. So whatever you multiplied it by, whatever you divided it by, it's going to be tiny. So what we get to the point is we can say, actually, we've gone far enough. The next term will be so small it would barely change the answer. Okay, actually what we've got here is an approximate answer. Remember that squiggly equal sign means approximate, but it's a pretty good approximation. I mean, if I go back to the calculator and actually work out 0.975 to the power of 10, it's not bad, is it? It's not bad. And, you know, so we're correct to 3 decimal places. And, you know, if I did another term, you know, the 5th term in the sequence, it would become more correct. So depending on the application, it's good enough. And in fact, calculators use expansions like the binomial expansion to actually do calculations like this, because these approximations are very accurate, provided you've got enough terms in the sequence. Okay, here's the next example. Should we do it in 2 separate bits? So go on, firstly do your first 4 terms of the expansion and then come back to me. Okay, so I've expanded it. Coefficients, don't forget, are 8C0, that's always 1, 8C1, that's 8, 8C2 and 8C3. Could have used Pascal's triangle. A reminder about how to get to the NCR button, because it's a little fiddly. So you go to Option, second page, Probability, and it's there. And then I expanded it out. It's a little bit easier because it's a plus 2x, so no negatives to worry about. So 8 times 1 times 2x is 16x. 28 times 1 times, just be careful here, remember that's 4x squared, 2x times 2x. So 28 times 1 times 4, 112x squared. And this is 8x cubed, 2x times 2x times 2x. So that's 56 times 1 times 8 gives you 448x cubed. Okay, so I want this to give me an approximation of this. So I need to work out what x needs to be. 1 plus 2x, 1.02. So hopefully you can see that x would have to be 0.01 to make 1 plus 2x equal 0.02. Well, sorry, 1.02. So this is even smaller than the previous example. So the terms are going to get really tiny really quickly, because, you know, by the time I get to here, 0.01 cubed barely registers on the scale, doesn't it? Anyway, see if you can approximate the answer to 1.02 to the power of 8 using those 4 terms, and then look on your calculator to get the actual answer. Okay, so hopefully that you can see where that came from, and hopefully you can see it's a pretty darn good approximation. So this is what we get from the approximation. This is the actual answer, and our approximation is correct to 1, 2, 3, 4. Well, if we rounded it, so it's 4 decimal places, isn't it? Yes, it's accurate to 4 decimal places. So it's a pretty good approximation. Actually, sorry, no, it's not 4 decimal places, is it? That's 1716, and this is 1717. But it's still pretty good. It's a pretty good approximation, particularly given we've only done 4 terms in the expansion. So this is what I mean by using the binomial expansion for approximations. We'll work through one more, and then I'll give you some independent studies to try. It's always a little bit more fiddly when you've got negatives in there, but again, I'm going to go through this in 2 steps. I'm going to do the first 4 terms of 1 minus 5x to the power of 30 first, then I'll come back and we'll have a chat about how we do part B, and then I'm going to talk you through part C, because this is quite a common question about percentage error. Okay, so hopefully you're with me so far. You've got to be careful with these minus values of b, haven't you? So this is 25x squared. So when you multiply it by the 435, you get this. And this is minus 125x cubed. So when you multiply it by the 4060, you get minus that x cubed. Okay, final step then is to work out what value of x you need to turn this into this, and then work out your answer rounding it to 6 decimal places. Have another go. There we go. Actually, my calculator gave me more accuracy than that, but we were specifically asked to round it to 6 decimal places, so that's what I have done. Now you might say, well, why don't you just do 1 minus x and make x equal to 0.005? That's still a tiny number, so it's still going to give you a good approximation. And you're right, it's a historical thing. Before super duper calculators, it was a lot easier to work in powers of 0.001 manually, because I can easily, well, perhaps not easily, but it is possible to do that calculation manually, and so that's why we have 1 minus 5x and make x equal to that. Okay, what about this percentage error question? Let's have a little look at that. I'm going to move my calculator, move my paper. Hang on. Okay, so I've got approximate answer to 6 decimal places, actual answer as supplied by my calculator, and if I was asked to write that down, then I would do. But what they're after here is the percentage error. And when you do percentage error with this sort of thing, you want your actual, the correct one, on the bottom of the fraction. So it's approximate over actual, and obviously I'm not going to use a rounded value of the actual. I'm going to type it in on my calculator again. So I'm going to use the 6 decimal place value for my approximate answer divided by the actual value given to me by my calculator. So let's type that in. So fraction button, 0.860368 over 0.995 to the power of 30. Now that gives me the error as a decimal. So I'm going to multiply it by 100 to turn it into a percentage. So what that tells me is that my approximated answer is 99.9981161 of the actual answer. So it's smaller. How much smaller? Well, you might better work it out. I'm going to do 100 take away that answer. That tells me how much smaller it is as a percentage. So that's 0.00188%, and that's to 3 significant figures. And the question, sorry, can't see that, can you? That's to 3 significant figures. I'm not given any steer in the question, so that's the level of accuracy I'm going to use. So just to take you through that again, approximate over actual, that gives you the error as a decimal. Multiply it by 100 gives it to you as a percentage, and I just asked how far away from 100% was I. That's not a bad percentage error, is it? So it's not 1% out, it's not 0.1% out, it's not 0.01% out, it's much less than that. That's a pretty good error. Okay, just a couple of independent study questions. I'm conscious that I keep referring to these as binomial expansions. Sometimes they're referred to as binomial series. A series is a number sequence that you are adding up as you go. So there we go. Yes, just 2 on page 170 in the textbook. Question 7, the only difference there is that A isn't 1, it's 2, but it's exactly the same process. The approximation works because the value of B is small. It doesn't actually matter what the value of A is. And 11 is another one with the percentage error to calculate. So if I was only going to do one of those, I would definitely do 11, but it's worth, I think, having a look at both. So that's Wednesday's lesson sorted, and hopefully you'll get an email inviting you to the Teams lesson on Thursday, and that will be in your normal lesson time. So I'm not doing one lesson for both groups, I'm doing separate lessons for each group, and I look forward to hearing from you, and hope all continues to be well. Take care.